All right, I'm going to work two more problems for you, and I'll label these as examples if you're not quite sure. Let's start from this one. This is the fourth problem in, and there's still the other side too, but let's just try these two right here for you, and then I'll leave these bottom two for you to continue. But this one says, how many grams of carbon tetrachloride are there in 3.8 moles of carbon tetrachloride? So what's given? Okay, that's the information given. So write that down on the left. 3.8 moles CCl4. I write down the molecule too, because otherwise I'll forget and I'll get the wrong label. And that really helps me set up my fraction. So I want to get to grams of CCl4 over here. Okay. Now I got to set up a fraction that'll get between there. And that's usually just done with a fraction bar in parentheses. Okay. Grams of carbon tetrachloride. I have to remember what the mass is, all of these masses. Sometimes I'll write it right across the top here to help me out, because that's 12. Plus each carbon is 35.45, sorry. So two of them is 71, and four of them is 142. 142 and 12 is total, I'm taking this times 4. Okay, so that's 142 plus 12 is 154 grams. Okay, that's the total amount of carbon plus 4 chlorines. 12 plus 35 plus 35 plus 35 plus 35, okay? So that's 154. Now, I know that is what 1 mole of anything is. So I've got 3.8 moles of carbon tetrachloride. I want to get grams of carbon tetrachloride, so I'm going to make a fraction. What goes to the bottom of this fraction? Well, whatever the term is that you started with. Don't worry about the number, but just the unit. So I'm going to put moles of CCl4. Okay? Grams of CCl4 is what you're trying to get, so that should be on the top. Okay, grams of CCl4, moles of CCl4. Do you know a relationship between grams and moles? What 1 mole weighs? 1 mole weighs this amount up here. So 1 mole is a relationship you know is whatever the atoms all add up to be. Carbon and 4 chlorines is going to add up to be 154. Okay, so now how am I going to get to the answer? This is just a fraction, 3.8 over 1. The tops times the tops, divide by the bottoms, divide by the bottoms. So 3.8 times 154, okay, it's going to roughly turn out to be about a little less than 600, so it should be 5 something. I'm not sure, just because I can't do it all in my head that fast. But take 3.8 times 154. It should be right around 582, 583, 560 something. Okay, I just don't have that one in my head. I can't do that fast. Now let's go into the next one. 80 grams sodium hydroxide gives me how many moles? It's asking for how many moles of NaOH. Okay, this is starting. Here's the given amount right there, 80 grams of NaOH. Okay. Now, what I need is a fraction that changes from grams of sodium hydroxide into moles of sodium hydroxide. So I'm going to write a fraction bar. Which one goes in the bottom? Whichever you started with. The unit goes in the bottom, not the number. Okay, grams of sodium hydroxide on the bottom. I want to get it to the moles because that's what's being asked for. Moles of sodium hydroxide on the top. Okay, I know 1 mole weighs the same as a sodium, which is 23. Oxygen, which is 16, that's 39, plus 1 more is 40. And you'd be like, holy smokes, how do you remember that? Well, I've just done this for 25 years. They're starting to stick. But you may have to look them up. Have your periodic table on one side, you just got to look there and add them up. But it's 40 grams for every mole. Now this one's not too bad, right? Because if I just write this as a fraction, 80 times 1, divide by 40, divide by 1. All the tops times the tops, all the bottoms divided by all the bottoms. Every time you have a bottom number, you have to divide by it, okay? So 80 times 1 is 80. Divided by 40 is 2. That is 2 moles of sodium hydroxide. Okay? So the rest you should be able to do. That should be good enough for you to get a good start. Okay? Good.